Hey everyone, and welcome. We hear all the time about these huge, complex AI brains, but what if I told you that deep down it's all built on a simple kind of decision you probably make every single day? Today we're going to peel back the layers and look at that fundamental building block. Let's jump in.
Okay, look at this number 70 billion. When you hear about these massive AI models like Llama, this is the kind of scale we're talking about 70 billion parameters. I mean, it's a number so big it almost feels fake, right? Impossible to wrap your head around. So, what even are these parameters? What are these 70 billion little knobs and dials actually doing inside the AI? You might think you need a degree in advanced mathematics to get it, but believe it or not, the core idea is so simple, you've already used it. To understand those billions of parameters, we're going to bring it all the way back down to earth. We're going to start with just a single, simple decision, a choice anyone can relate to. So, let's say you're thinking about buying a new bike. It's a classic yes or no situation. How does your brain actually process that? Well, it probably does something that looks a whole lot like this. All right, let's break this down. First, step one, you list out the factors. These are our inputs. Do I have the money? Do I need it? Is it safe to ride where I live? Is the weather generally good? Step two, we just give them a yes or no value. We'll use 1 for yes, 0 for no. So money, yes, that's a 1. Need it? Yep, another 1. Safe? And let's say no, so that's a 0. Now, step 3 is the really important part, the weights. See, not all factors are equal. Money and need are super important, so we'll give them a heavy weight of 3. Safety is important too, let's say a 2. And weather, well, it's a factor, but less critical, so it gets a 1. Step 4, we just do some simple math. Multiply each value by its weight, add them all up, and we get a total score of 7. And finally, step 5, the decision. We all have a kind of mental threshold, right? Let's say ours is 6. Well, our score of 7 is bigger than 6, so the answer is yes, we're buying the bike. Okay, so why did we just go through all that trouble for a bicycle? Because, and this is the cool part, you just ran through the exact logic that powers the most basic unit of an AI's mind. That's right. That whole thing, the inputs, the weights, the score, the threshold, that is the logic of something called a perceptron. Congratulations, you just did the core calculation of an artificial neuron right in your own head. So, here it is, the perceptron. It's the simplest possible version of an artificial neuron. It takes in a bunch of inputs, multiplies each one by how important it is, the weight, and adds it all up. Then, a little gatekeeper at the end, the activation function, just checks if the final score is high enough. If it is, it shouts 1 for yes. If not, it says 0 for no. That's really it. And you know, this isn't some brand new futuristic idea. The concept has actually been kicking around since 1943, and the first working perceptron was built way back in 1958. It's truly the original building block of all of this. And the inspiration for it, as you can probably guess, comes straight from nature. On the left, that's a real neuron from your brain. Those little branching bits, the dendrites that receive signals, they're just like the inputs on the perceptron on the right. The cell body that adds it all up, that's our summation function. And the axon that fires off a signal, boom, that's the output. It's literally a man-made brain cell. Okay, so we get what a perceptron does, but how does it learn anything? Well, the secret lies in those parameters we talked about at the beginning, the weights, and another really important piece called the bias. I love this quote from Analytics Camp. It says to think of parameters as the brain cells of AI models, and it's so true. When we say an AI is learning, what's really happening is it's just tweaking and tuning these millions of little weights and biases to get better and better at a task. This is where the knowledge is actually stored. And this table just makes that connection perfectly clear. The factors from our bike decision, in AI, those are called inputs. The importance we assigned, yep, those are the weights. That minimum score we needed to hit, that's the threshold, or the activation function. And our final yes or no, that's the output. It's a one-to-one translation from our brain to the machine. So what's the difference between a weight and a bias? It's pretty simple if you think about it visually. Imagine you're trying to draw one straight line to separate two different groups of dots on a graph. The weights control the angle or the slope of that line. They tilt it. But just tilting isn't always enough. That's where bias comes in. The bias lets you take that entire line and just shift it up, down, left, or right without changing the tilt. To get the perfect separation, you need both, the right tilt and the right position. And this is exactly what training an AI looks like at its most basic level. The perceptron keeps trying to draw a line. If it gets an answer wrong, it just slightly adjusts its weights and its bias, nudging the line, changing the angle a little bit, and it tries again. It just keeps doing this over and over, thousands of times, until it finds the best possible line that separates the two groups. So a single perceptron is a pretty clever little decision maker. But here's the catch. On its own, it's actually not that smart. It has a pretty big weakness.
It's got some serious limits. For one, it's only good for those simple yes or no questions. But the real problem, the big one, is that it only works if you can separate your data with a single straight line. If the pattern is any more complicated, like the famously tricky XOR problem, a single perceptron just gives up. It can't do it.
But what happens if you don't use just one? What if you connect thousands of them together? Or millions? Or, even billions of these simple little decision makers? Well, that's when the magic really starts to happen. And this is a neural network. Each one of those little dots is basically a perceptron. But by linking them up in layers, the decisions from one group of perceptrons become the inputs for the next group. It's this teamwork that lets the network as a whole learn incredibly complex, curvy, nonlinear patterns that a single one could never even dream of. Which brings us right back to where we started. We now get it. We understand that one simple little perceptron can make a decision like whether or not to buy a bike. So the question to leave you with is this. What becomes possible when 70 billion of them, each with its own little tunable weights and biases, are all working together? That is the mind-blowing scale of modern AI.